Good morning, children. Today we are going to derive a formula n2 by v minus n1 by u equals n2 minus n1 by r. What are the terms? n2 refractive index of second medium, n1 refractive index of first medium, v image distance, u the object distance, and r as usual distance between the pole and the center of curvature. We have already studied that when light ray travels from a rarer to a denser medium, it bends towards the normal. Now the rarer medium, medium 1, we have taken as n1, medium 2, its refractive index as n2. But remember, here the surface of separation between the rarer medium and the denser medium is a straight line. But this relation n2 by v minus n1 by u equals n2 minus n1 by r, we are going to derive when the surface of separation between the two medium is a curved surface. You can see a curved surface here separating two medium, a rarer and a denser medium. Rarer medium, refractive index n1, denser medium, refractive index n2. A ray of light, when it is going straight, it is not bending from the first medium to the second medium, it is going straight. Now O is the object. Another ray from the object, it is going and falling obliquely on the surface of separation. What happens when the ray falls obliquely? It bends towards the normal because this is rarer, this is denser. Now how do you find out the normal? We have already studied that normal is the line passing through the center of curvature. So this is angle of incidence, angle between normal and incident ray. This is angle of refraction, angle between refracted ray and the normal. And the ray, refracted ray, and this straight line meets over here and you get the image here. This is the center of curvature. So this is the distance r, this is the image distance, this is the object distance. This diagram, refraction at a spherical surface separating two medium. You can find out this in your textbook, refer figure 9.17. Remember, media is the plural of medium. This is one medium, this is another medium. This is a plural of medium. So from this diagram, we are going to derive the relation n2 by v minus n1 by u equals n2 minus n1 by r. So let us move on to the derivation. For deriving the relation n2 by v minus n1 by u equals n2 minus n1 by r, consider this diagram. You are familiar with the terms. This is the object, this is the image, object distance, image distance, r, angle of incidence, angle of refraction. This is the normal, rarer medium with refractive index n1, denser medium with refractive index n2. Now observe this diagram very carefully. We are going to take the help of a little bit of trigonometry. Consider the triangle NOM. The triangle NOM. Is this a triangle? Is this a straight line? I told you this is a curved surface. But if this angle is very small, we can consider this as a straight line. Understand, this is a magnified image. So if this angle is very small, you can consider this as a straight line. So you can consider this as a triangle also. What about the tan of this angle? For that, you have studied in trigonometry that if you have a right angle triangle, if this angle is theta, this is the opposite side, this is the adjacent side, and tan theta is equal to opposite side by adjacent side. This we are going to apply in this triangle. So what is the tan of this angle NOM? Tan angle NOM is equal to opposite side MN by adjacent side OM. So that is what is written here. Tan angle NOM is equal to opposite side MN by adjacent side OM. Now look very closely to another triangle, triangle NCM. Triangle NCM, this angle. This is a triangle and observe this angle. What is the tan of this angle? Which is the opposite side? This one, adjacent side, this one. So tan angle NCM is equal to opposite side MN by adjacent side MC. So tan angle NCM is equal to MN by MC. Now consider this triangle NIM. Triangle NIM, this long triangle, the big triangle. What about the tan of this angle? Tan angle NIM. Again, opposite side by adjacent side. This long side is the adjacent side. So opposite side is MN and adjacent side is MI. So tan angle NIM is equal to MN by MI. Now observe this diagram again carefully. I told you this is the angle of incidence. Now I want you to observe triangle NOC. Listen very, very carefully. Triangle NOC. For triangle NOC, angle I is an external angle. Angle I is an external angle. You have studied that external angle is the sum of internal opposite angles. XAB is equal to sum of the internal opposite angles, angle B and C. Similarly, external angle ACY, this is an external angle. It is equal to sum of the internal opposite angles. Which are the opposite angles of these two? Angle A and angle B. This we are going to apply in our derivation. In the diagram, external angle I is sum of internal opposite angles, angle NOM and angle NCM. Okay, so let us apply that. So from triangle NOC, external angle I or angle of incidence is equal to angle NOM plus angle NCM. But what is angle NOM? We have already studied that tan angle NOM is equal to MN by OM. But if angle NOM is very small, we can say that tan theta equals theta. This we had already studied. For small angles, sin theta equals theta, tan theta equals theta. This is not applicable to cos theta because when sin angle is 0, sin 0 equals 0. When the angle comes very close to 0, since sin 0 equals 0, we can say that for small angles, sin theta equals theta. Similarly, tan theta is also equal to theta. This we are applying in our derivation. So applying these values in our derivation, let us see how we can apply this in the derivation. In the derivation, instead of MN by OM, instead of tan angle NM by OM, tan angle NOM, we are writing MN by OM. And this one, tan angle NCM, we are writing this one. Why? Because angle of incidence is angle NOM plus angle NCM. Angle NOM is this one. We are not taking tan because for small angles, I told you tan theta equals theta. So instead of tan, we can simply write MN by OM. And tan angle NCM, instead of that, we can simply write MN by MC. Why? Because angle of incidence is equal to sum of the opposite angles. These are the opposite angles of this triangle. Angle I is sum of this one and this one. NOM and NCM. So instead of NOM and NCM, I am writing MN by OM and MN by MC. Where did we get that from? From these two relations. The same thing we are going to apply for the angle of refraction. Okay, that also you have to listen very carefully. Which one is the angle of refraction? This is the angle of refraction. Now I want your full attention to this triangle. Triangle NCI. This triangle. ഈ ചരിഞ്ഞ് കിടക്കുന്ന triangle. This one. And triangle NCI. This angle is the external angle of this triangle NCI. Which are the internal angles? This angle R and this angle I. So this angle NCM is equal to sum of R and NIC. So I can write that angle R is equal to this angle minus this angle. Okay. How did I get that? From triangle NCI, R is equal to angle NCM minus NIM. I hope you have understood that. R is an internal angle and the external angle was angle NCM. Angle NCM is equal to sum of the internal opposite angles. These are the internal opposite angle, these two. So I can write that R is equal to external angle minus the other internal opposite angles. And instead of these two, I can write Mn by Mc like we did here. Mn by Mc minus Mn by Mi. Since we have got the values of I and R, we are going to apply Snell's law. What is Snell's law? Sin I by sin R is equal to N21. That was the second law of refraction. N21 can be written as N2 by N1. So sin I by sin R is N2 by N1. Let us cross multiply. N1 sin I is equal to N2 sin R. Again, for small angles, sin I can be written as I and sin R can be written as R. So instead of sin I, in this relation, instead of sin I am going to write it as I. Instead of sin R, I am going to write it as R. So N1 sin I becomes N1I. N2 sin R becomes N2R. Okay. So we are going to substitute the values of I and R in our derivation. I and R values we have already found out in our derivation. Let us substitute that. So substituting the values of I and R, this is the value of I, this is the value of R. In the relation, N1I is equal to N2R. So instead of I am going to write this value. Instead of R, I am going to write this value. Okay, let us substitute. So instead of I, Mn by Om plus Mn by Mc. Instead of R, Mn by Mc minus Mn by Mi. We can divide the whole equation by Mn. So what happens? All the Mn's get cancelled. Okay, and open the bracket. When you divide by Mn, all the Mn's get cancelled. You can cancel Mn on all the sides. And let us open the bracket. When Mn goes, you get 1 by Om, 1 by Mc, 1 by Mc, 1 by Mi. Let us open the bracket with N1. N1 by Om plus N1 by Mc is equal to N2, open the bracket, N2 by Mc minus N2 by M1. Rearranging, we are bringing this minus N2 by Mi to this side and we are taking this to this side. Because Mc and Mc we have common terms. So we are bringing this term to this side. So N1 by Mc goes this side and this negative term we are bringing it to the left side. So rearranging, we get N1 by Om, this is remaining here. This term minus term has come this side, N2 by Mi, and this term has gone this side. Now Mc is common here. We can take it as common. So N1 by Om plus N2 by Mi is equal to N2 minus N1 by Mc. Mc is common here. Now from the diagram we know that OM is U and MI is the image distance V and MC is radius of curvature R. Now using sign conventions, I hope you remember sign conventions. All the measurements taken from the pole to this side should be taken as negative, and to this side, that is the direction of light, this side is positive, this side is negative. Okay, so OM, this side we are taking, U is this side of the pole, so U we have to put a negative sign. These two measurements are positive. So plus V plus R. So we are going to put the values of OM, MI and MC in our relation. Let us substitute. So substituting the values of OM, MI and MC. Instead of OM, I am going to write minus U. Instead of MI, plus V. Instead of MC, plus R. So instead of OM, I have put minus U. Instead of MI, plus V. Instead of MC, plus R. So now here we have N1 by minus U plus N2 by plus V is equal to N2 minus N1 by plus R. Since this is negative, we'll put this term to this side, minus N1 by U. This is positive, we'll bring it to this side, N2 by V. And here, no need of making any change. So this was the relation that we were trying to derive. N2 by V minus N1 by U equals N2 minus N1 by R. So homework, derive the relation N2 by V minus N1 by U equals N2 minus N1 by R. You can refer page 323 and 324 in your textbook.